So, human effects on ecosystems is our last lesson in ecology. So, I'm not going to have you write all of this down into your notebook. I'm going to go through it very quickly and just read through the slides, do some explaining to you, and then we're going to go back through and I'm just going to make a list of things that you should write into your notebook. Okay, so human effects on ecosystems. Loss of habitat and fragmentation. So loss of habitat is where things live, so losing that. So farmland, human settlements, and highways have replaced much of southwestern Ontario's temperate forests. Like I've mentioned before, we do live in a temperate deciduous forest area, but unless you go to places like the Pinery and other kind of wildlife reserves, you're not going to see what it's supposed to look like. Fragmentation means dividing up a region into smaller pieces of land, and it's reduced the sustainability by exposure to pollution and loss of shelter and food. On a global scale, habitat loss is second to climate change as the most serious threats to sustainability of natural terrestrial ecosystems. Sustainability means how healthy they are and how likely they are to survive into the future, and terrestrial means land-based ecosystems. Expanding populations are placing pressure on the land base to supply more food and more raw materials for people. The Amazon, not the company, but the Amazon rainforest, which is the largest rainforest, is being cleared and burned for cattle pastures to be sold to the foreign market. Number 2, loss of wetlands. Human activity along shorelines for waterfront property, dredging for boats, sediment runoff, commercial fishing, and draining wetlands for agriculture. Anything there. Dredging is when you're modifying the bottom of rivers and streams so that boats are able to go in. Sediment runoff is like when it rains, the sediment can be dissolved in that rain and run off into lakes and streams, etc. This has all led to habitat destruction, shoreline erosion, and loss of species and loss of breeding areas. We're not making it easy. Watershed and contamination. And I'm not going to have you do this. We're just going to use this as one of the ways, one of the reasons that we're hurting ecosystems. Non-native species. Introduction of new species can be successful. However, ecosystems may lack population control, such as natural predators. Native species might not be able to compete with the new species. Invasive species. I should say invasive. A non-native species whose intentional or accidental introduction negatively impacts the natural environment. Global damage caused by invasive species is around $1.4 trillion annually. That's globally how we have to deal with these invasive species. Let me just take a quick look if we have an example. Yeah, invasive species in Ontario. We've got the emerald ash borer. I had to take down an ash tree just last year, as a matter of fact, kind of the last ash tree that we had, and it finally succumbed to the ash borer. Zebra mussels. They're supposed to live, I think, overseas in Europe, and they attached themselves and got onto the hulls of fishing boats or shipping boats, I should say, and then they got into our lakes, and they crowd out a lot of different species. Asian carp, I know, is an invasive species, but I don't know much about their history. Purple loosestrife crowds out different plants. There's a picture of it down there. And the purple loosestrife crowds out other plants and makes it so that they can't grow. They look nice, but they are not good for the ecosystem. The round goby, I think that's the picture of them there. The giant hogweed, that's I don't want to say a newer one, but it's an invasive species that's actually quite dangerous, and phragmites. One that's not, these are just examples, right? We're not even going to write these down into our notes. Maybe we'll write one example just to make sense of it. But I know that they brought in Japanese ladybugs to deal with, farmers actually had them shipped in to deal with the fact that aphids were on the bean plants eating the beans. So these ladybugs, which are typically they are the type of ladybugs you see nowadays. They like to eat aphids. They love to eat aphids. So we brought in many, 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 many in the millions or billions of these ladybugs to eat the aphids, and they just loved it here. The climate was perfect for them, and they have no natural predators here. Nothing eats these ladybugs, so they just exploded in population, and they actually crowded out our regular ladybugs. Non-native species. Three main ways to control non-native species. So they can be non-native, just simply means that they don't belong in that area. So chemical controls like pesticides can kill non-target species, and they pollute the air, water, and soil. Mechanical controls are using physical barriers or physically removing them. Biological controls, you intentionally introduce a new organism to try and control that one. Well, that may or may not be a good idea. So, for example, if those ladybugs are out of control, then that's suggesting, well, what does normally eat the ladybugs in their natural habitat? And let's get some of those, and then where does it end? Next, looking at pollution. Pollution just means harmful contaminants released into the environment. It can be the air, it can be the ground, it can be anywhere. Two major factors affecting the relationship between humans and the environment are drastically increasing the size of our population, and many toxic and persistent chemicals have been invented to support our lavish lifestyles. Some polluting materials have a specific purpose, like pesticides and fertilizers, and others are our consumer society, like automobile exhaust and packaging. So packaging would mean like plastics and things like that. Automobile exhaust means we're burning oil-based products and putting that pollution into the air. Fertilizers can help your grass grow, but they can run off into lakes and streams, and they cause big algae blooms, which harms the ecosystems. And pesticides can have a negative impact on a variety of ecosystems. Number 5, acid rain precipitation. That just means, it's just acid rain. So combustion of fossil fuels, oil-based products, and metal ores during industrial processes releases sulfur dioxides, that would be SO2, and nitrogen oxides, something like NO3 or NO2, into the air. These gases form acidic compounds in the atmosphere that fall to Earth as acid precipitation. So it's not like you might see in a dramatization. It's not going to burn your skin. It's not good for your skin. We're just creating rain and precipitation that's very slightly acidic. So over time, they can wear away buildings and things made of stone, and they can cause metals to rust more quickly and eat away at them. Can also cause respiratory problems, things like that. Well, let's look at them right here. So acid deposition can have devastating effects, such as can kill fish, plankton, and aquatic plants. Things in aquatic ecosystems are especially sensitive to the amount of acids that are in their ecosystem because they rely on the water. They rely on the oxygen and nutrients that they can get out of the water. So changing the pH is just a way of measuring the concentration of acid in a liquid. So changing that pH, either too low or too high, can have devastating effects on aquatic ecosystems. It can prevent nutrient uptake by plants. That means affecting the soil. It can damage leaves and tree tissue, which makes them more susceptible to invaders. It damages buildings and corrodes our cars. It can amplify respiratory problems like asthma and bronchitis. So by that, I mean, there's always an amount of moisture in the air, even when it's not raining. So if there's some acidity there in that moisture, then you're breathing it into your lungs. Dilution is not the solution. Now, that's just a goofy quote from, I think it was back in the 1980s when Brian Mulroney was Prime Minister of Canada. And that was one of the slogans, dilution is the solution. Dilution is the solution, meaning if we burn fossil fuels, we should be building giant smokestacks to push all that pollution up as high as we possibly can because it's not going to harm us in the upper atmosphere. The problem is that creates a lot of other things. It puts carbon dioxide into the atmosphere, which accelerates global warming, and it causes acid precipitation, and some of them can damage the ozone layer. That's what that statue is supposed to look like, and that's what it looks like now. And there's a bunch of dead fish. There's a forest that's been devastated. I guess we're going for it's done by acid rain, but could have been a number of things that causes those trees to die. Hold on. I'm just trying to get out of that. Holy smokes. All right, well, you're just going to have to bear with me for a moment as I try and stop whatever is causing all that nonsense. Discard my annotations, and we'll go back into it. Just click something that I probably was leading me to a link that didn't exist. We'll get back to where we were. Pollution, acid rain, here we go. Dilution is not the solution. Next, oil spills. There's been a few in the news. I don't know if there's been any big ones that you can remember. One off the Gulf of Mexico I can recall from just a few years back that dumped billions of tons of oil into the Gulf of Mexico, and obviously that's going to have many negative impacts. So water's our most important resource. Oil tankers navigate the world's oceans, and accidents can happen, which have devastating effects on ecosystems. Oil is toxic, slow to break down, and difficult to clean up. An oil spill can be a problem because seabirds and seals ingest the oil when trying to clean themselves, and the oil on their fur and feathers makes them lose their ability to insulate, and they die from the cold. The following 4 examples are methods to capture and break down or disperse any oil: skimming or vacuuming, bioremediation, that's introducing microorganisms that actually feed on the oil. That's kind of a cool one. Burning, oil floating on the surface is sometimes just lit on fire, which prevents it from sinking to the bottom, which is just going to make it go away while turn into other forms. And there are such thing as dispersal agents called detergents. Detergent is no different than what you'd use in your dishwasher to wash. Certain hand soaps are also detergents, and they can break down oils. Are we leaving that at that? Let me just see. I just want to bring to your attention, because I know it's one of the assessment questions, is kind of a disadvantage of burning. Problems of if you're dealing with an oil spill by just burning it off. Well, that's not good. That's putting all sorts of carbon dioxide and other pollutants into the atmosphere, which causes more global warming and just adds pollution to our air. Plastics is an extremely useful material. It's inexpensive, it's lightweight, it's strong. These advantages are what make plastic so harmful. It does not chemically degrade. It lasts for hundreds. It's more than hundreds of years. Plastics just don't break down, right? So all the plastic that's in our landfill, in the dump, in the great big Watford dump, all that plastic is going to be there till long after your grandkids are gone. Unless they move it, but it will not break down. It's not like, if you put a banana in a landfill, it's going to break down in the matter of weeks. But plastic lasts for many, 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 many years. Each year, over 1 billion kilograms or 1 million tons of plastic are produced worldwide. Most plastic ends up in landfills, but some of it enters waterways and oceans. Sunlight and wave action break down the plastic into small pieces, which the animals eat, blocking their digestive systems, and some animals can get entangled in it. Plastic also poses a threat through the manufacturing of it, such as the air pollution and consumption of petroleum. Believe it or not, plastic is an oil-based product. It's a petroleum product. So it requires the use of oil to make it. Number 8, toxins in the environment. Bioaccumulation refers to the accumulation of a toxic chemical in the tissue of a particular organism. Biomagnification refers to the increased concentration of a toxic chemical the higher up the food chain you go. So what that means is that if you just have a little bit of a contaminant at a low level in the food chain, as you go up the food chain, it's going to be more and more. Because, for example, if we look down here at this seal or sea lion or whatever that is there, it's going to gain a little bit of this toxin every time it eats one of these fish that just has a little tiny bit of toxin. All right. So that's going to build and build and build. And let's say this polar bear eats the seal. Every seal he eats, he's going to gain that large amount of toxin. And that's what biomagnification means. Just remember this. It's an increased concentration. The higher the food chain you go, the more predominant it is, because they gain and they keep all of the toxin from each of those little animals that they eat. Number 9, resource management. Natural ecosystems are an important source of valuable resources. 60% of the original forests in Canada have been cut at least once. 3 main categories. Clear cutting, that means cutting down all the trees in an area. Shelter wood cutting, which means you just cut some of the trees. And selective cutting means you're just taking down the ones that, I don't want to say are dead or dying, but you're taking down ones that aren't going to affect the ecosystem. And expense is the main issue. I don't know if it's obvious from where you're sitting, but clear cutting an area is the cheapest way to do it. Take in a big machine, cut down all the trees, use all the wood that you can use, and they just throw out or burn the rest. Soil is one of the most important resources on Earth. It's composed of 3 layers: the topsoil, the subsoil, and the bedrock. So, and we've got arrows here to describe each of those. It's pretty self-explanatory there. So there's those 3 layers. I want to talk about, still talking about deforestation and cutting down trees. So roots of trees and plants help hold all these layers together. If they aren't there, then a lot of these nutrients and a lot of the soil can be run off into lakes and rivers. Number 10, agriculture. As crops are harvested, the valuable nitrogen, phosphorus, and potassium is removed and doesn't return to the field. So fertilizers, materials used to restore nutrients and increase production from land, are introduced, because the farmers take the nutrients out and they have to add them with natural fertilizers, which is manure, generally speaking, or synthetic fertilizers, which is less smelly but more expensive. Agroecosystems. Agriculture ecosystems have more uniform abiotic features, lower biodiversity, and they're intensively used by humans and need to be maintained. And I mentioned this in a lesson a long time ago. By a long time ago, I mean 2 days ago, which seems like a long time ago. This word monoculture, right? The farmer's goal is to make everything in his field the same, right? He wants just wheat in his wheat field. So that's what's meant by monoculture, a cultivation of a single crop in an area. For example, a wheat field. What else do I want to say anything else about that? Well, it does make the ecosystem more susceptible to issues, because a monoculture will have very low biodiversity, and ecosystems that have a low biodiversity tend to, they always are weaker. So that whole ecosystem can collapse and stop supporting the little wildlife that it does support. Environmental impact. With the addition of nitrogen and phosphate added to the soil, surface runoff carries decaying plant matter and fertilizer-rich soil into streams and lakes, like I mentioned on that last slide. I don't know what happened there. Can I write? Yes, I can. Nutrients allow algae in the water to grow more rapidly, and that's called an algal bloom. So there's a picture of that. That's that bottom picture here. If you ever see a pond, it usually happens in bodies of water that are a little smaller. And you can see all that green yuck that goes on top of there. Algae grow and die. Decomposers flourish with the abundant food source. Oxygen levels in the lake will drop drastically, and fish and other animals die. So it drastically changes, and not for the better, for the worse. These algal blooms. It's very bad for the lake ecosystem. My parents, they have a cottage up north, and they sometimes do see algae starting to bloom in their lake, and they try and get rid of it as fast as they can, because if it takes over the lake, then their place could become worthless, I should say, if they can't control the algae levels. Nobody wants to go swimming in a lake that's covered in algae. Other concerns, another problem is the presence of nitrates. Nitrates are converted into nitrites, which are dangerous to animals that have hemoglobin in their blood. We have hemoglobin in our blood. You learn about that in grade 10. Nitrates can attach to hemoglobin in the blood, reducing its ability to carry oxygen to bodies and tissues. It's very serious for young animals, including humans. Alternative practices that can be used would be no-till farming. They leave the ground undisturbed after harvesting crops, and that helps keep the soil nutrients in. It reduces the water loss, and it reduces runoff as well. Crop rotation reduces the use of fertilizers because they use the dead plant matter from one crop to help fertilize the next. And that's mostly what we see around our place. They usually rotate beans, wheat, and corn. Crop selection, crops suited for local conditions, so they don't have to add a whole lot to it to make it work. So that's our last slide in ecosystems. Now, what you can do is just go through and make a summary note. Everywhere where you see a number, you should make a note of it. And by number, I mean human effects on ecosystems. All right, number 1, habitat loss and fragmentation. And then you don't have to write anything else about that. Just that's one effect that humans have on ecosystems. And then we talked and talked and talked. Number 2, loss of wetlands. Hopefully you can see where I'm going with this. Number 3, watershed and contamination. Now, watershed just means it's basically our wetlands areas, usually near Wallaceburg. And it's where, well, you can kind of see it right here, how the water from the land, that includes lakes, rivers, streams, and that runs off into larger lakes and then eventually into oceans. That's what a watershed is. Non-native species, number 4. And we talked about non-native species. Number 5 was acid rain precipitation. Number 6 was oil spills. Number 7 was plastics in the environment. Talked quite a bit about plastic. Number 8 was toxins in the environment. Number 9 was resource management. Number 10 was agriculture. And that was it. So how many things were that? Let's just go back 1 slide here, or 2 slides, or 3 slides. There we go here, 10. There were 10 things. 10 things about human activity that affect ecosystems. So if you just make a list and just write down those 10 things, I think that that's sufficient for your note on this. You may have to revisit this slideshow, though, if when you're doing your assessment today. So feel free to do that. If I can't remember if I have any questions there that will go into more detail about exactly how some of these things affect it, but feel free to look that stuff up. It's essentially, I could use it as a test, but it's not really a test, but it's what I'm using as your test in this unit. So, but it's open book, open notes, use the assignments and stuff that I've posted to help you through it. All right. So what next? What next? I'm just going to get off of this and just kind of show you what else is in store for you this learning block. So I've been going for a while here, and I'm going to go down here into block 3 and click edit so you can see what I've posted for block 3. So what you've got is it's a length. Yeah. Right now you're viewing a lengthy lesson on human activities and effects on ecosystems. It says it's lengthy, you don't need to copy it down. And then you've got the ecology multiple choice assessment. You can use your notes and use your assignments. Take a break when you're done and be back on Google Meet for 1:35. All right. So the ecology culminating assessment is there. It is a Google form, just like the one you did on space. This one's all multiple choice, no written questions. So I think that you will get feedback on how you did on it right when you're finished. And I'll also get that mark as well. And I'll put it right into our grade book. All right. So that's all I need to say about that. You guys, good luck on that, and jump onto Google Meet if you have any more questions. Okay. Good luck, everybody.